Okay, last one, example 7. The graph of force against elongation for wires P and Q are shown in figure. The wires have the same original length and the same cross-sectional area of 4 mm square. Okay, we are given a graph of force against elongation. So the force here is in Newton and elongation is in millimeter. So sama untuk kedua-dua wire P and Q. First question, calculate the work done to extend wires P and Q by 1 mm. Hence, state which wire is more rigid. Second one, from the graph above, deduce the ratio of Young's modulus for wire P and Young's modulus for wire Q. Okay, so wire P and Q, kita dibagi, they have the same length, okay, the same original length and the same cross-sectional area, which is 4 mm square. Okay, now we want to calculate the work done to extend the wire by 1 mm. So we need to find work done. Okay, the value for W. Okay, daripada graph F against E, dekat sini kita boleh dapatkan apabila kita apply 100 Newton of force on the wire will extend by 0.5 mm. So apabila 200 Newton, wire akan extend by 1 mm. So samalah juga untuk this one. Okay, so since dia minta the work done when the extension ataupun elongation adalah 1 mm for each wire. So kita boleh dapatkan daripada wire P, kita boleh dapatkan apabila kita letak, kita apply 200 Newton of force, the wire will elongate by 1 mm. So kita boleh terus dapatkan gunakan value ni. Okay, so remember before this, work done is actually equivalent to energy. Work is energy, energy is work. So basically we can find the work done by using the energy formula, which is equal to half Fe. Okay, so we are going to use this formula here. So untuk wire P, okay, kita gunakan, kita cari wire P dahulu. U sama dengan 1/2 F, ni adalah wire P kan tadi. F adalah 200, elongation 1 mm. So F is 200, elongation is 1 mm. Make sure you convert to meter. U is equal to 0.1 joule. Okay, next one for wire Q. So for wire Q, this one here. Okay, so daripada graph untuk wire Q, we are not given the exact value for when the elongation is 1 mm. Sebab soalan minta apabila 1 mm, which is somewhere around here. Okay, but we can actually calculate that one. Okay, based on the pattern here. So, apabila kita apply 250, it will elongate by 2 mm. And then kita double the force. Okay, kita tambah lagi 250. So, kita letak, kita apply force to 500 Newton. So, the elongation will extend by 4 mm. So, tambah 2 dekat sini. Ni pun tambah 2. Kamu boleh nampak kan pattern dekat sini. So, meaning that when the elongation is 1 mm here, we can get the force is 125. 250 ni kita kena bahagi 2. So, 125 Newton. So, the value for U adalah sama dengan half. F is 125. This one is 1 mm. So, U will be equal to 0.0625 joule. And then soalan tanya which wire is more rigid. Okay. So, kita boleh compare in terms of energy here. So, the energy stored for the wire P is larger than the energy stored for the wire Q. So from here we can conclude that wire P is more rigid. Okay, because apabila kita apply 200 Newton, which is force yang lebih tinggi berbanding dekat wire Q kita apply sedikit saja force tu, 1 to 5 Newton. Dan dia elongates by 1 mm. So this one 200 Newton elongates by 1 mm. So we can conclude that wire P is more rigid than wire Q. Wire Q ni sikit je kita apply force tu, dia sudah elongate by 1 mm. Okay? Alright, so next one. Soalan B, from the graph above, deduce the ratio of the Young's modulus of wire P to the Young's modulus of wire Q. So we want to find the ratio. Young's modulus of wire P to Young's modulus of wire Q. Okay, so meaning that here we need to find the Young's modulus of each of these. Okay. Since, okay, kita keluarkan dahulu formula untuk Young's modulus, which is F L0 divided by AE. Okay, so since dekat sini, we are not given the value for the original length, and elongation pun kita tidak dibagi, kita dibagi in terms of graph. Okay, in terms of graph, and then force pun dibagi in terms of graph. We only have the value for the area here. Okay, so what we can do, since dia minta ratio, meaning that YP divided by YQ, so meaning that here FPL0 divided by AE divided by FQL0 divided by AE. Okay, so soalan mention that here both wires have the same length and the same cross-sectional area. So this one sama, this one sama. Wait, this one and this one adalah sama. So dekat sini kita boleh cancel out. Okay, kita boleh cancel out, di mana kita akan dapat FP divided by elongation, FQ divided by the elongation. Okay, so now, okay, we need to decide which value for force that we want to use. Okay, apabila kita decide a value for force ni, elongation mesti sama. So kita decide lah, kita gunakan apabila elongation 1 mm. So untuk wire Q, force 125, untuk wire P, force adalah 200. So these two must be the same. Kita gunakan E sama dengan 1 mm. Meaning that here we can also cancel them out. Bermaksud YP divided by YQ adalah sama dengan FP divided by FQ. So FP tadi adalah 200, FQ adalah 125. Equal to 1.6, ataupun you can leave your answer in terms of fraction at divided by 5. Sebab dia minta ratio, so you can either leave it like this or like this. And ratio, we don't have unit.